Now after the discussion of your velocity and acceleration analysis, we will move towards our next chapter, that is gears and gear trains, right? This is a very important chapter if we talk about gate perspective. So first of all we will discuss about the gears, then after that we will go with the chapter gears train or gear trains, right? Gears are those mechanisms which are of higher pair, right? Gears are the higher pair mechanism. Higher pair, we know that higher pair means when two links are connected with the point of contact is either a line contact or a point contact, right? So we can say that gears are your toothed wheels, right? On the wheels we have some tooths, and it is used to transmit, gears are used to transmit constant angular velocity. This is important. It is used to transmit constant angular velocity ratio between two shafts, right? Now suppose in a mechanism we have so many shafts and we want different angular velocities at different shaft, suppose, or you can say that you want to transmit the power from one shaft to the other shaft, right? And there is a large distance between them or small distance, whatever it may be. So we can say that if we have two shafts, suppose these are the two shafts, right? And we want to transmit the power from this shaft to this shaft, right? So the power will be transmitted from this shaft to this shaft with the help of gears, and gears are the toothed wheels which is used to transmit the constant angular velocity ratio. The angular velocity ratio between these two shafts will always remain constant at each and every point, right? At each and every instant we can say the angular velocity ratio will be constant, right? So we can say that we are not talking about constant RPM, right? I am not saying constant RPM. Revolution per minute is not constant. Why? Because we can say that if we talk about revolution per minute, right, constant RPM, so we can say that your RPM is the average of 1 minute rotation, right? Revolution in 1 minute. Suppose in first 30 seconds revolution are more, and after 30 seconds the revolutions are large, right? So we can say that on an average, if we take, then we have a constant or an average RPM. But we are saying that the gears are maintaining the constant angular velocity ratio at every instant, right? At each and every instant. So if I write here, if I extend this definition, so it will transmit the constant angular velocity ratio between two shafts at each and every instant. At each and every instant. This is the difference between RPM and your constant angular velocity, right? So in the system it may be the case that for the 30 seconds, let us say for 1 minute, we are talking about 1 minute, for the 30 seconds the angular velocity is such that the revolutions are 30, and for the next 30 seconds suppose the revolutions are 50. So the revolution per minute will be the average of this, right? So we can say that we are not talking about the constant RPM, because constant RPM is an constant angular velocity, right? Is an average angular velocity, you can say. Constant RPM will be calculated based on the average angular velocity. But we are saying that we want to transmit or we want to maintain this constant angular velocity ratio at each and every instant, right? So that can be used with the help of, that can be transmitted with the help of gears. And these shafts where we want to transmit the constant angular velocity ratio or power, so these shafts may be parallel like this, these shafts may be intersecting, right? The shafts may be at some angle, or the shafts may be like this, they are neither parallel nor intersecting, right? They are not parallel nor intersecting. So the shaft can be of any configuration, but the gears can be used to transmit the power between these shafts, right? Now suppose if we talk about, let us say we have, suppose this is your disc 1, right? Let us say this is your disc 1, and suppose this is your disc 2. Suppose this is your disk 2, right? So if I write here, suppose we can say that this is your disk 1 and this is your disk 2, which are mounted on shaft. Let us say this is one shaft in this plane and this is another shaft, right? This is the another shaft and this is the center of rotation, or the shaft you can say. Here we have shafts. So we can say that, suppose this is a line joining these centers, this is the line joining this center, and let us say the point of contact, this point is P. Let us say this point of contact is P. So if this disk 1 is rotating with an angular velocity, let us say omega 1, right, in the anti-clockwise direction, so this will rotate in an anti-clockwise direction, sorry, clockwise direction with an angular velocity omega 2, let us say omega 2, right? And the radius of rotation for the disk 1, this radius is, let us say, R1, and the radius of this disk 2 will be R2. The radius of disk 2 will be R2. So these two disks are at a point contact, so this is a higher pair between them, right? You can see this is a higher pair between them. So if we talk about point of contact, if we talk about this point of contact, let us say P, point of contact P, this point of contact is on both the disk, right? So we can say, if this point of contact, we are saying that this is on the body 1. If this point of contact is on body 1, then what will be the velocity of this point P? This will be equal to R1 omega 1, right? This is the radius, this is omega 1, so the velocity of this point will be R1 omega 1. If this point of contact is on the body 2 or on the disk 2, you can say, so what will be the velocity? Velocity will be R2 into omega 2. Velocity will be R2 into omega 2, right? And if we can say that if there is no slipping, so, and or you can write, if this disk is rotating without slipping, if this disk is rotating, if these disks are having rotation without slipping, without slipping means these disks are in pure rolling. These disks are in pure rolling, then we can say that if there is no slip between these two disks, then these two velocities will be equal. Obviously, if there is no slip, then this is the same point, so the velocity of this point P will be same. So I can say that in this case, R1 omega 1 will be equal to R2 omega 2, right? From here I can say that the velocity ratio, angular velocity ratio omega 1 by omega 2 will be equal to R2 by R1. R2 by R1, and you can see that this is constant. This is constant. Right? This is constant. So this is the basic function of the gears. These are the two gears which are in contact at some point, let us say the point of contact, and this is maintaining the constant angular velocity ratio that is equal to R2 by R1, right? This is the constant angular velocity ratio, and this is only possible when these two gears are rotating without slipping. That means these two bodies will be in pure rolling, right? This is the meaning of this rotation without slipping, means pure rolling. There should not be any slip at the point of contact. So these two circles will represent two gears, and we will discuss in the nomenclature of the gear. Just you can say that these circles, these imaginary circles which are at contact at this point P, these are known as pitch circle. These are known as pitch circle, right? We will discuss this later on. So these circles are known as pitch circle, and these will be represented a gear. So the angular velocity from this gear, the angular, or you can say this is the input shaft. This shaft is rotating with angular velocity omega 1. So this disc or this gear is connected with this shaft. So this disc is also rotating with an angular velocity omega 1. So from this shaft we want to transmit the power to this shaft. So how the power is transmitting from this shaft to this disc or gear 1, from this gear 1 to this gear 2, from this gear or disc 2 to this shaft. This is the flow of power. So hence the power will be transmitted from one shaft to the another shaft, and in this example both of the shafts are parallel, right? These are in the parallel. The axis of rotation of these shafts are parallel in the plane perpendicular to the plane of this board, right? So this will be the basic concept of gears, right? These are the basic concepts of gear. Now we want to classify the gears. Now we want to see what are the various classification of gears. Gears can be classified in a number of ways. First, we will see that on the basis of axis of shaft connected. On the basis of axis of the shaft connected, we can say that the axis of the shafts can be parallel, they can be intersecting, or they can be neither parallel nor intersecting. First of all, let us talk about when both the axes are parallel. Both the axes of the shaft are parallel, right? So if both of the axes of the shafts are parallel like this, right? If I attach a disc here and if I attach a disc or gear on this shaft, then if this gear is rotating, that it can transmit the power, or it can rotate this gear also, right? So the gears which are used to transmit the constant angular velocity ratio between two parallel shafts, those are known as spur gears. Those are known as spur gears, right? Spur gears, in the spur gears we can say that your teeths are straight and parallel to the axis of rotation. Teeths are straight. In this, teeths are your straight and parallel to the axis of rotation. So if suppose this is a shaft, if this is a shaft, this is the axis of rotation. If I put a disc on this, then the teeths will be like this. Then the teeths will be like this, parallel, straight. First of all, it will be straight and parallel to the axis of rotation. So those gears are known as spur gears, right? Spur gears. Now, if we talk about the spur gears, suppose these two are the teeths of spur gear, right? We have these two shafts, right? On this we have one gear and on this we have another gear. The tooths are in the direction of axis of the shaft. Suppose these two are the tooths. Now assume these two are the tooth. Now when they come in contact, because these are the straight and parallel to each other, when they come in contact with each other, right, when this disc is rotating and when this teeth will come in contact with this teeth, these both are straight, so complete area will be in contact at a instant, right? This complete teeth will be in contact with this complete teeth at one time, right? So we can say that because if this is the case, the teeths are parallel, so we have a sudden engagement, right? This disc is rotating like this, this gear is rotating like this, so this teeth will have a sudden engagement with this teeth, right? It will have a sudden engagement with this teeth. So this is the problem. Because of this sudden engagement and sudden disengagement of the teeth, because they are parallel, they are straight, then there is a impact stress generated in this case. Very high impact stress will be generated, and because of this impact stress, the vibrations are generated, and there is a large chance that gear will fail because of this high impact stress on the gear tooth, right? So if I draw the diagram, suppose let us say this is first gear, right? Let us say this is first gear. Similarly, just we can say that, let us say this is the second spur gear. They both are in contact with each other at this teeth, right? This is the second spur gear. Suppose this is the axis of the shaft of this gear 2 on which this gear 2 is placed. This is the axis of the shaft. and for the gear 1, let us say this will be the axis of the shaft. This will be the axis of the shaft, right? And we can say that the tooth on these gears will be like this. If I show the tooths, they will be like this, straight tooth parallel to the axis of rotation. This is the axis of rotation, right? If you can see from here, these discs are rotating like this. So this is the axis of the rotation. So the tooth will be parallel to the axis of rotation. These will be parallel to the axis of rotation like this. Right, these are the straight tooth on gear 1. Similarly, for the gear 2, we can say these are the straight tooths for gear 2. These are the straight gears on gear 2. Right. Now, because in this case of this spur gear of having parallel tooths or straight tooth parallel to the axis of rotation, in this case, because of the sudden engagement and disengagement, there is sudden engagement of one tooth with the other tooth of other gear. Sudden engagement is there, and because of this sudden engagement, very high impact stress will be generated. Very high impact stress will be generated, and this is the limitation of this gear, that because of this high impact stress, there is a more wear and tear. Life of this gear will be very less, vibrations will be generated, and so many noise will come. So this is not preferable to use the spur gears having straight teeth parallel to the axis of the rotation because of this limitation. But the one advantage of this spur gear is that in this case your axial thrust is 0. In this case your axial thrust is 0. This is the advantage of this, right? You can see from here, suppose these are the two teeths of two gears. When they will come in contact with each other, every point on this gear will be in contact with every point on this of this tooth, right, like this. So the force will be in this direction. Suppose this is the driven, right? This is the driven gear and this is the driving gear, or you can say this is the input, this is the output. So when this gear will come in contact with each other, all the force will be in this perpendicular direction. Complete force will be in this perpendicular direction. So the component of this force in the axis, along the axis of the rotation, will be 0, right? Because they are come in contact like this. So along this axis of the rotation, along this axial thrust, the component of the force will be 0. And why we want this axial thrust to be 0? Because you know that, suppose this is a shaft, right? This shaft is holded in a bearing. Bearing will be used to hold this shaft. So if there is an axial thrust in this direction along the axis, if a force is coming, then that force will be applied on your bearing, and then bearing life will be less. Then bearing life will decrease. So we always want that in that system, if bearing is involved, so we can say that there should not be any axial thrust. So this is the only advantage of having spur gear, that their axial thrust will be 0. But because of this high impact stress and because of this sudden engagement and disengagement, the high impact stress will be generated. Because of this, more vibrations will be generated, and this is not preferable for high speed. If there is a high speed, then the force will be more. So the spur gear with having straight tooth parallel to the axis of rotation, this is limited to your low speed transmission or low power transmission, right? Now, if you want to overcome this high impact stress, we are preferring the helical gears. What do we mean by helical gears? Helical gears having the tooths are straight. Now also tooths are straight but inclined to the axis of rotation. But now they are inclined to the axis of rotation. Suppose this is the axis of the rotation. We have a disc here. Now the tooth is not straight like this. Suppose this is a tooth on this gear, right? Now the tooth is not straight. It will be having some inclination toward your gear, right? It will be having some inclination with respect to this axis of rotation. Some inclination will be there. right? So we have two gears. Suppose we have two gears. On one gear, suppose the tooths are like this, inclined, the another gear having tooth like this. So when they will come in contact with each other, so only a point contact is there, not a surface contact. Only a point contact is there. So because of this point contact, and when the motion will continue, so the contact will be like this. Then from it will start with a point contact, then it will be in an area or surface contact, and then they will disengage at a point contact. So this will be the contact profile, right? It will start with a point contact, then it will come near and a surface contact, and then they will disengage at point. So this is the advantage, because complete area is not coming, complete tooth is not engaging with the another tooth. So that's why, because of this, your impact stress is minimized. Because of this, the impact stress is minimized. But the problem with the helical gear is that if you can see, if these two tooths are coming like this, right, and this is the axis of rotation. If two tooths are like this, suppose I'll write like here, suppose this is one tooth, this is another tooth. If they are coming in contact with each other at this point, this is the axis of rotation. Suppose this is the axis of the shaft. So now when this tooth is coming like this, it will exert a force in this direction. It will exert a force in this direction, and this force is having some, let us say this is F, theta angle is there. So this component F cos theta will be along the axis of rotation. So because of the helical gears, this axial thrust will come. This is the axial thrust. F cos theta is a axial thrust, right? So this is the only disadvantage of helical gears, but we have some methods to avoid, to minimize these axial thrust. We will discuss later on. First of all, let us draw the diagram of the helical gears. And obviously in the helical gears, opposite hand helical gears must be in contact, right? If one gear is having a right hand helix, then another gear will be having a left hand helix, so that the contact will be point contact, and when the motion is continuing, then it will be a area contact, surface contact, and then they will disengage at the point contact, right? So opposite hand helical gears must be in contact with each other. So suppose if I draw the diagram of this, let us draw the diagram of this helical gears. Suppose this is your gear 1. Let us say this is your gear 1. Suppose the teeth on this gear will be like this. They are inclined to the axis of rotation. They are inclined to the axis of rotation. Not now parallel to the axis of rotation. They are inclined to the axis of rotation like this. Right? They are now inclined to the axis of rotation. Suppose the axis of rotation of this gear is this one. This is the axis of the shaft. Now they are having at some angle with the axis of rotation. Now let us say another gear will be in contact with each other, with this gear. Another gear is this one, let us say. The another gear which will be in contact with this gear is this one. And now on this gear, suppose the teeths will be in opposite hand. Opposite hand. If this is right hand helix, then on this second gear, on this mating gear, the helix will be left-handed helix, like this. Like this. It will be left-handed helix. Opposite helix must be there. Suppose this is the axis of this shaft. This is the axis of the rotation of this gear. Right? This is the axis of the rotation of this gear. Now we can say that in the helical gears, we have gradual engagement and disengagement. Here we have sudden engagement and disengagement, but in the case of helical gears, we have gradual engagement and disengagement. Right? The engagement will start with a point contact, then it will moving to the surface contact, and then they will disengage at the point again. Gradual engagement and disengagement, and because of this gradual engagement and disengagement, your impact stress is less. But the disadvantage is with this is your axial thrust is generated. Axial thrust, now this axial thrust will come, and we want that this axial thrust will be as low as possible. This axial thrust will be as low or as small as possible. Why? Because this axial thrust will affect the life of the bearing which will be holding these shaft, right? So to minimize this axial thrust, if I write, to minimize this axial thrust, we are using double helical gears. We are using double helical gears, in which in the same gear we have both right-handed helix and left-handed helix. So if I want to draw the diagram of this double helix, so let us draw the diagram. We are talking about the helical gears. Now let us draw the diagram. Suppose this is your gear 1. Suppose this is your gear 1, and let us say this is your gear 2, which are in contact with each other. Right, this is a gear 2. They are the, you can say they are the double hand helix. So we can say that suppose we have one tool run out in between, two, because we need a tool run out. Why? Because to make this, because you want to manufacture this gear, right? To manufacture the gears, the tool must be moving, right? Tool must move. So tool will be moving in the tool run out. Suppose this is a tool run out, right? This is a tool run out. Now the gears will be like this, the teeth will be like this, or rather we can say teeth will be like this. On one side we have, suppose this is right-handed helix, on the other side we have left-handed helix, like this. Both hand helix will be present on double helical gears, like this, right? Similarly, in this one, if this is your right-handed, then this will be your left-handed, like this. The gears will be like, the teeth will be like this in these two gears, right? These will be the tooths on these two gears. So this is your double helical gears, and this space is known as tool run out. This space is known as tool run out. This is the passage so that your cutting tool will move. Cutting tool will move in this direction so that it will be able to cut these profile of the teeth, right? So this is your double helical gear. This is your double helical gear. On the same gear we have both right hand helix and left hand helix, right? Double helical gears. So in this case if we talk about, we have very minimum axial thrust. In this case we have minimum axial thrust. Why? Because you can see from here. Why? Because when these tooths are in contact with each other, suppose this teeth and this teeth will be in contact with each other. Suppose this is the driving, so let us say this is the driving link or driving gear, and this is the driven. This has to be driven, right? So suppose this is the input, this is the output. So we can say that suppose this is the input shaft or input gear, this is the output gear. We can say when suppose this teeth will be in contact with this teeth, right? This is the input, this is output. So if this teeth will be in contact with this teeth, so this teeth will apply a force on this teeth in this direction, right? If this is in this, the force is in this direction, then the component along the axis of the shaft will be in this direction. Similarly, if this teeth of the input gear will come in contact with this teeth of the output gear, then if this teeth will be in contact with this gear, with this teeth, then this teeth of the input gear will apply a force on this teeth in this direction. So the component will be along this direction. So we have two axial thrust. One is for this half gear, another one is for this half gear in two opposite direction. If they are in two opposite direction, we can say that if they are equal, they will cancel out each other. In general, we can say because we have the two axial thrust in opposite direction, so the net effect will be to minimize the axial thrust. Net effect will minimize the axial thrust as compared to the single-handed gear or single helical gear. So if we can say that, suppose if there is no tool run out, just for your objective question, this question will not, this much theory will not be required for GATE. If tool run out is not there, then the helical gear is known as ideal helical gear, and the name of that gear is herringbone gear. If tool run out is not there, then the double helical gear is known as herringbone gear, right? When this tool run out is not there, then this tooth will be like this. Suppose if I make the diagram, suppose this is the one gear, so the teeth will be like this. If this is the case, this is known as herringbone gear, right? Like this is your herringbone gear. So this is the case when the shafts where we want to transmit the constant angular velocity ratios are parallel to each other, then we have to use this spur gears or helical gears. So this is the concept of the first classification or first type of your spur gear. Now the second type in the classification of gears based on the axis of shaft, the second one is when both the axes of the shaft are intersecting, right? Like this. When both of the axes of the shaft are intersecting, we can say that the pure rolling motion can be transmitted between two conical surfaces in contact, right? If I put two conical surfaces in contact, then the pure rolling motion can be achieved. Suppose this is your shaft 1 and this is your shaft 2, right? They both are intersecting at this point, right? They are not parallel. So we can say that the pure rolling motion can be achieved with the help of these conical surface, and if there is a tooth on these conical surface, then it can act as a gear. So we can say that these type of gears are known as bevel gears, right? These type of gears are known as bevel gears. Now bevel gears are also of two types. If the teeths are straight and teeths are parallel to the axis of rotation, then we have straight bevel gear. Straight bevel gear means when the teeths are straight, we can say when the teeth are straight and parallel to the axis of rotation. And parallel to the axis of rotation. Right? If the teeths are straight and they are parallel to the axis of rotation, suppose this is a bevel gear, and if teeths are straight and parallel to the axis of rotation, like this. Second one type is when the teeths are inclined to the axis of rotation, then we have helical bevel gear. Helical bevel gear. Helical bevel gear means we can say that in the helical bevel gear we have the teeth are straight but inclined. In the helical bevel gear also we can say your teeth are straight but inclined to the axis of rotation. Inclined to the axis of rotation or axis of shaft. Right, these are of two types, straight bevel gear and helical bevel gears. Right, now suppose if these two shafts are perpendicular to each other, let us say if these two shafts are perpendicular to each other, suppose this is your shaft 1 and this is your shaft 2. This is the axis of the shaft 1 and this is the axis of the shaft 2. They are perpendicular to each other. Now these are connected with the help of two bevel gears like this. These are connected with the help of two bevel gears, and if these two bevel gears are similar, if these two bevel gears are, I can write here, if these two bevel gears are similar, right, then these are known as mitre gears. These are known as mitre gears, right? And if these are dissimilar, if they are not similar, these two bevel gears are not similar, then obviously they are just simple bevel gears. But if they are similar and connected to perpendicular shafts, then they are known as mitre gears, right? This is the everything about your when two shafts are intersecting with each other. Now the third one is, we can say that the third one is C, when shafts are neither intersecting, when shafts are or the axes are neither parallel nor intersecting. If they are not parallel or intersecting, you can write in place of shaft, you can write axis, right? That will give you better understanding. When the axis of rotation of the shafts are neither parallel nor intersecting, like this. If these are the two shafts, they are not parallel and not intersecting. So in this case, we can say that in this case, pure rolling is not possible. Pure rolling is not possible. In this case, we have rotation with sliding, right? In this case, we can say that pure rolling is not possible and rolling is possible with sliding. That means we have rotation and sliding also. So in this case, the gears which are used to transmit the power from one shaft to another shaft are known as spiral gears. They are known as spiral gears, right? They are known as spiral gears, and some other names are also there, that when the space between the two shafts is very less, right? When the space between the two shafts are very less, then the gears are known as hyperboloid, and also they are known as or hypoid gears. Hyperboloid gears, another name of these gears are hyperboloid gears, right? That may be asked in the objective question of your engineering services, not necessary for the GATE perspective. In the GATE, only numerical will come, but for the better understanding of the chapter, we'll see some of the theory portion. So this is the first classification of the gears based on your axis of the shaft, right? First one is the spur gear when the axes are parallel, second one is the bevel gear when they are intersecting, and third one is the spiral gears when the axes of the shaft are neither intersecting nor parallel, right? The next classification is according to the type of gearing. We can say that the next classification is on the basis of type of gearing. Second classification is on the basis of type of gearing. Type of gearing. So on the basis of type of gearing, we have two different types of gears. One is your external gear, another one is the internal gear. First one is your external gears. And another one is the internal gears. Right, we will see one by one. Suppose, let us say, first of all let us talk about the external gear. Suppose this is the gear 1, right, and let us say this is the gear 2. Suppose this is a gear 2. They are in contact with each other externally. The external surface is in contact with each other, and suppose this is the line joining the center of the two shafts, right? Now suppose we can say that, let us say, suppose this is the gear 1 and this is the gear 2, right? If you can see that if this gear is rotating in clockwise sense omega 1 with the angular velocity omega 1, then this gear will rotate in the anti-clockwise sense omega with some angular velocity omega 2. So just remember that in the external gears, the direction of rotation of both the gears are opposite. If one is moving with a omega 1 angular velocity in clockwise sense, then another one will be in the anti-clockwise sense. But in the case of, this is your external gearing. This is the example of external gearing. Now if we talk about the internal gearing, like this, suppose this is the gear 1, this is your gear 1, and inside this, let us say we have another gear 2. Suppose this is gear 2. This is in contact with this gear 1 like this, right? Let us say this is your gear 1 and this is your gear 2. This is the center point. Here the shaft is there for gear 2, and let us say here is the shaft for gear 1. Here is the shaft for gear 1. So if this gear 1 is rotating in anti-clockwise with an angular velocity omega 1, then this gear will also rotate in the anti-clockwise direction with an angular velocity, let us say omega 2. So in the internal gears, the direction of rotation of the angular velocity or the direction of rotation is same. In this internal gears, the direction of rotation or the direction of angular velocity is same for both of the mating gears. Those gears which are in contact, their direction of rotation is same. But in the external gears, we can say that the direction of rotations are opposite. The direction of rotation are opposite. If one is moving with clockwise direction, then another is moving in anti-clockwise direction, right? So these are the basic classification of the gears. Now we can say that after this, let us move towards the next topic of the gears, that is the gear terminology. We have to discuss some of the basic gear terminologies. After that, we will go with your analysis of the gears, right?